Right, we have this particular Euclidean geometry question, and we shall proceed to answer a couple of questions that pertain this particular question, second geometry question or Euclidean geometry question. Right. In the diagram, PQRS is a cyclic quadrilateral such that PQ equals PR. Right, so we're able to see that PQ equals PR. It has been given the tangents to the circle through P and R, meet QS produced at A. So QS has been produced and the tangents meet QS produced at the point A. Moreover, RS is produced to meet tangent AP at B. So we're able to see that RS itself is produced to meet tangent AP at the point B. Now, PS is produced to meet tangent AR at C. We can see that here. PR and QS meet at M. Okay, there. Okay. Right, now proof giving reasons that angle S3 equals angle S4. We need to prove that angle S3, okay, this is the point S, so we need to prove that angle S3 is equal to angle S4. So there are different ways to mark that. We can mark it like as follows, like this. Okay, so we have S3 here equals the angle S4 like this. Want to prove that these two angles are equal to each other. Right, and to prove this is very straightforward. We start by saying first things first. The angle S3 is equal to angle PQR. And this means, therefore, here you have the exterior angle of cyclic quad. Okay, so we have the exterior angle of cyclic quad. This becomes the reason. We're able to see first and foremost that the angle S3 is equal to the angle PQR, this one here. And why is S3 equals to PQR? Because the exterior angle of a cyclic quad. Mostly, obviously, you need to understand that this is the cyclic quad we're talking about here. Let's just do this to make sure that we're on the same page like this. So S3 is equal to PQR, exterior angle of cyclic quad. So the exterior angle of a cyclic quad equals the interior opposite angle. Okay, so moreover, we have angle R3. Angle R3. Right, and now we are able to see that at this point, the angle R3 here is actually also equal to the angle PQR. And why is this the case? It is the case because of the fact that we have angles opposite equal sides. Okay, we remember that PQ equals PR. So if PQ equals PR, therefore these are like base angles. So R3 equals PQR, angles opposite equal sides. And obviously, if this is the case, so the conclusion we can draw, therefore, is that therefore the angle S3, therefore the angle S3 is R3. Okay, they are equal to each other. So S3 equals R3, and this is true because obviously they are both of these angles equal to PQR. Okay, but the angle S4, this one here, right, the angle S4, this here, is actually equal to the angle R3, this one. So in other words, the angle S4 is actually equal to the angle R3. Why is this the case? These are angles in the same segment. Angles in the same seg. Okay, angles in the same segment. Okay, this is true because of angles in the same seg, in the same segment. Okay, but obviously, I mean, seeing these here, what is then the conclusion? The conclusion is that therefore angle S3 is therefore equal to the angle S4. Right, so, and this is what we're to show, that S3 equals S4, and we've proven this step by step. Right, a very, very interesting question, but yeah, we've since arrived at the answer to this question. Yeah, so thanks everybody for taking part in doing that one. Let's look at the next question. So the next question is 10.2. Want to prove that obviously want to prove, giving reasons, that SMRC is a cyclic quadrilateral. Right. So want to prove that here is S, here is M, and here is R, and here is C. Right. It's a cyclic quadrilateral. So let's proceed to prove that one. Right. So once again, we're here and we want to prove that S, M, R, C is a cyclic quadrilateral. Okay, now let's prove this. And we see how these can be proven. Okay, so yeah, let's just take note of that. Take note of this and look at the proof step by step. Now, there are a couple of things that are very important. Like, if you look at this, you're able to see that angle R1. Okay, now to prove that SMRC is a cyclic quad, first and foremost, we take angle R1. We can see that angle R1, if you add angle R1 to R2, we are able to agree that this angle here is equal to angle PQR. Why? Because of what we call the 10 chord. 10 chord theorem. So R1, R2 equals PQR, and it is the 10 chord theorem. The angle between a tangent to a second and a chord equals the one in the alternate segment. Right. Moreover, we have angle S4. And angle S4 is equal to angle PQR as well. Okay. I'm going to just analyze that, but it is true that the angle S4, okay, this here S4 is equal to the angle PQR. Just note that angle S4 equals the angle PQR. Obviously, I mean, we remember that we're able to establish that fact that at this pointer S3 is equal to S4, which is equal to PQR. So S3 equals S4 equals PQR. So yeah, just note these things. Okay, so what do we do? We proceed to say that S4, this one here, is equal to PQR. What is the reason? The reason is that this was proved. It was proved in 10.1 above. It was proved in 10.1 above. So just take note of that. Okay, what is then the conclusion here? Okay, the conclusion here is therefore that the angle S4 is equal to R1 and R2. Is equal to angle R1 and angle R2. Right, so because they're both equal to PQR, so you can say that S4 is equal to R1 plus R2. Now, let's look at this, what the implication is. If S4, this here, is equal to R1 added to R2, like this, then what conclusion are we able to draw here? What conclusion can we make? And the conclusion that we can make is SM RC. Okay, right, is that SMRC is a cyclic quad. It's a cyclic quad. Okay, it's a cyclic quad. Why? Okay, we're gonna just analyze that together just now. This is cyclic quad. Why is SMRC a cyclic quad? Well, we have already seen that at this point, this angle S4, this angle S4, this one is equal to R1, R2. Now, this here is this situation. This type of a situation. Just watch this. So the angle S4 is equal to R1 plus R2 because we have the reason for this is it is the converse. Okay, the reason is the converse. Okay, the converse of exterior angle of cyclic quad. Exterior angle of cyclic quad. Converse of exterior angle of cyclic quad. Right, so this is the result, converse of exterior angle of cyclic quad. Okay, it is the converse because we're having that exterior angle of this quad equals the interior opposite angle, and therefore that means that we have a cyclic quad. Okay, so we have been able to prove 10.2 with so much ease. Okay, just note that part. And so we continue to look at 10.3. Right, proof giving reasons that RP is a tangent to the circle passing through, okay, P, S, and A at P. So we are saying RP. Right, so at this point, you have R and P. There's a circle that passes through P, S, and A, right? P, S, and A, right? So in other words, we need to show that at this point, RP is a tangent. If you look at the circle that passes through, okay, let me mark this point so that we not forget. There's a point P here, there's a point S through which the circle passes, and there's a point A through which the circle passes, and we are effectively then saying RP itself becomes a tangent to this particular circle where this is the point R. At the point P, if this is to be the case, the circle passes through this point, so you can see that this angle here, one way to establish that is to see that this angle here, which is the angle P2, is going to be the angle subtended by this particular chord, which is the angle the A2. So let us actually proceed to argue these. But first things first, we realize that the angle S3, the angle S3 is equal to RP plus P2. It's equal to R2 plus P2. Okay, S3, right, which is this one here, is equal to R2, which is this one here, plus P2, which is this one here. So in other words, we see that the angle R3, this one here, is equal to this together with this. And obviously this is grade 10, and it is the exterior angle of triangle. So the exterior angle of triangle. So the exterior angle of triangle is the sum of the interior opposite angles. Moreover, we have S4. Right, here is S4. Right, the angle S4 itself is equal to angle P1 plus the angle A2. Let's analyze this together. So we're arguing that the angle S4 is actually equal to P1. So here is the angle S4. We're arguing that it is equal to the angle P1, which is this one here, plus the angle A2, okay, which is this one here. And obviously, that is due to the grade 10 results. Okay, the grade 10 results. Okay, let's just do this here. So we're able to see that the angle S4 is equal to this plus this. Okay, so, and this is the exterior angle of triangle. Okay, we have already established from 10.1 that the angle S3 equals S4, so that we're able to have that R2 plus P2 is equal to P1 plus A2. Okay, let's look at this. Let's look at this. Right, because S3 equals S4, then this is the conclusion that can be drawn. Okay, you can put that as a reason. Angle S3 equals S4. And this has been proved in 10.1 above. Okay, now let us analyze this together and be able to see and note that, but it is true that angle P1 is equal to angle R2. Right, so let's just clean up a little bit here. It is true that the angle P1 is equal to the angle R2, and this is due to an obvious result, the 10 chord theorem. 10 chord theorem. Right. And the conclusion, therefore, if it is true that those P1, the angle P1 is equal to the angle R2, so these ones you can cross out. And after you cross them out, we're able to make the conclusion that the angle P2 is equal to the angle A2, like so. Okay, let's look at what this means now. So if P2 is equal to the angle A2, it is our old result from grade 11. Okay, this is obviously a metric concept, but yeah, this is from grade 11, and we are able to celebrate this. So if this equals this, and the conclusion, therefore, is RP is a tangent. So in other words, therefore, RP is a tangent. So RP is a tangent. Is a tangent to the circle. And why is this the case? What is the reason for this? Right, the reason for that is because of the converse 10 chord theorem. Converse 10 chord theorem. Okay, there are a couple of things about the converse 10 chord that are important. So just take note of this here and make sure you understand this very, very well. Okay, we have established this, yeah. So exciting stuff. And in other words, we've been able to prove the results. What results have we been able to prove? Because we considered that RP is a tangent to the circle that passes through the point P, the point S, and the point A at the point P. So we've been able to show that RP indeed is a tangent, so that the angle between the tangent and this particular chord equals the angle in the alternate segment. And we've been able to prove that. Yeah, thanks everybody for joining us. A very exciting proof. And goodbye to you.